All right, so we are adding to section 8.1. So if you want a title in this, 8.1 more sequences, or you can just pick up where you left off. And a few things that I want to say first. A few notes. Is if you add, oh gosh, I'm kind of seeing the issues. If you add or subtract, if you're adding or subtracting to get to each, if you are adding or subtracting by a number that is not constant, a sequence is going to be quadratic. And what I mean by when you are adding or subtracting by a number that isn't constant, what I mean by that is that you are adding 1, and then you add 3, and then you add 5, and then you add 7, etc. When that happens in your sequence, you have what's called a quadratic sequence. And I will talk to you about how you come up with a rule for that in just a minute. I just want you guys to get these few notes in your notes first. If it is constant, so if you are adding or subtracting by a constant, what's it called, you guys? When you are adding or subtracting by the same thing every single time, then what does that mean? It's linear. Yeah. In other words, you are, I'm going to squeeze in here. You are adding 2. You're adding 2. You're adding 2. You're adding 2.
I guess you had to. Can you like recalibrate that pen?
Etc. Yes, Corey?
What if, yeah, well, maybe you might cover this in a second, but what if you added like 1, 2, 3, 4, 5? Is that?
You're adding 1, then you're adding 2, then you're adding 3, then you're adding 4. That would be quadratic.
Even though there's like a pattern to it?
Yes. There's a pattern to this one too, which is the odds, you know. All right. Can I flip pages, you guys?
Yeah.
Yes.
Yeah. If and only if.
If multiplying, and some of you might wonder, well, what about dividing? Well, if you are multiplying by the same number each time, sometimes you might be multiplying by a decimal value less than 1, which would be the same thing as dividing. So when I say if you are multiplying, that kind of implies that if you are dividing also. So if you are multiplying by the same number, in other words, a constant number, does anybody remember what it's called?
Exponential.
Very good.
Because there's not anymore.
So, for example, you are multiplying by 3, and then you are multiplying by 3, and then you are multiplying by 3, multiplying by 3, etc. That's constantly happening. You have what's called a exponential situation. So let's look at some examples now. First example, let's say you have the number 1, the sequence 1, 4, 7, 10, 13, etc. Okay, I'm ready for the heat to be on. Just feels so much better now. It took the edge off. All right, how do you get from 1 to 4 to 7 to 10 to 13?
3.
You had 3. You're constantly adding 3. So what? Look back at your notes. What does it say when you are constantly adding the same number?
Constant.
It's linear. Yeah. So that means if it's linear, we have a what of 3 in this case? We talked about that on Friday. It took us a long time to figure out that if you were constantly adding the same number to get to each next number, it was
Slope.
yes, it had a slope. It has a constant slope. So to get from 1 to 4 to 7 to 10 to 13, the rule in that case would be a sub n is equal to, we're constantly adding 3, so it's going to be a sub n, and all we're doing is we're kind of like writing a y equals equation. This a sub n here is the same thing as a y equals if you were to type this into your calculator to find the string of numbers. So a sub n is equal to, we are constantly adding 3, so it's 3n, but this is the deal, we have to figure out a starting value. In other words, we have to find a y-intercept. Where are we starting in this case?
1.
Very nice, very good. I tried to trick you. I did trick some of you, but some of you I did not. We are not starting at 1, because when they give you this list of numbers, you have to assume that the first number they give you is a sub 1. So to write your sequence, or your rule for your sequence, you need to work backwards one step and figure out what would happen if you were to have a 0 term. What would be a sub 0? So if you are adding 3 to go from 1 to 4, and then adding 3 to go from 4 to 7, and so on, you have to work backwards one step, and you work backwards one step by subtracting 3. So if I subtract 3 from 1, you get negative 2. So if you were to go to y equals now and type in 3x minus 2, and then create a table, this is what your table would give you. The 0 term in your table would be negative 2, the first term would be 1, the second term would be 4, and so on. Are you okay with that?
Yeah.
That's pretty much just review of Algebra 1. You had to create your own rules.
Do you know what unit that is?
Actually, Unit 3, I believe. Alright, let's try this one. Let's say that you have 2, 5, 10, 17, excuse me. Can I flip you guys?
Two.
Alright, so we have 2, what did I say? 2, 5,
10, 17.
10, 17. Alright, I'm going to, you can do this for all of the situations if it is helpful. I'm going to create a table here, and on the top, I'm going to put n's, on the bottom, I'm going to put my a sub n's. So my a sub n's, they represent my answers, my y values. In other words, the values that you have in your sequence, and then the n's represent the term number. So on the top, I'm going to put 1, 2, 3, 4, and I could keep going if I needed to, but I probably don't need to. What is the very first term? Very first term is 2. What is the second term?
5.
Second term is 5. The next term is 10. The next term is 17. So, if it's helpful, go ahead and do this. You might not need to do this.
Oh, I get it.
How do you get from 2 to 5?
3.
You had 3. How do you get from 5 to 10?
5.
You had 5.
7.
How? So I said,
I'm excited.
if you are adding or subtracting by a pattern, but that pattern is not necessarily a constant pattern, what did we say that it was? It was going to be a quadratic pattern. So when I say quadratic, that means that you are going to have a what in your rule?
A square.
You're going to have a square. Very good. So we need to come up with a pattern, or a square, something with an n squared in it. So this is where you got to be maybe a little bit creative. Try to come up with a rule. Like, what are we doing to these numbers on the top to get the numbers on the bottom? We are adding 1. What else are we doing? We know it has to be, we have to have a squared in there.
Multiply by itself. I think.
Multiplying by itself. And what?
Adding 1.
Adding 1. So if I took 1 and squared it, 1 squared, and added 1, what is 1 squared plus 1?
2.
It's 2. What about 2 squared plus 1?
5.
2 squared is 4, plus 1 is 5. What about 3 squared plus 1?
I'm done.
3 squared is 9,
10.
plus 1 is 10. 4 squared plus 1, 4 squared is 16, plus 1 is 17. What's the rule then? A sub n equals what?
N
N squared plus 1.
N squared plus 1.
Anthony, you figured that out?
So whenever this is happening, whenever you're adding by a pattern like that, you got to think about it being an n squared, and typically you maybe double the n squared and add something, or maybe it's just n squared and you're subtracting a couple of numbers. But you need to be thinking in this direction. You're gonna have an n squared in there. Okay? Let's do
Just like that.
let's do this.
We do 2 more.
Remember she said he's gonna have a square.
We have 2, we have 3 over 2, we have 4 over 3, we have 5 over 4, and we have 6 over 5. So the only number that looks slightly strange in this pattern is is the 2. Why does the 2 look kind of strange?
It's over 1.
Can we make it over 1?
Yeah, make it over 1. Make it over 1, and
That
that
would
might
make
look
sense.
make this a little bit nicer. And I'm gonna make another table here. So on the bottom, I'm gonna put my a sub n's. So my first a sub n is 2 over 1. My second a sub n is 3 over 2. My next one is 4 over 3. And whenever this happens, it might be helpful sometimes to think of the numerator and the denominator as being completely separate rules. The numerator and denominator are completely separate rules. So term 1 is 2 over 1. Term 2 is 3 over 2. Term 3 is 4 over 3. Notice my term numbers keep showing up in the denominators. Are you okay with that?
Yeah. Well, if that's how it's gotta be.
So when you're writing your rule, a sub n equals, what is in the bottom, what is in the denominator of your rule? The n. So first term n, if n is 1, there's going to be a 1 in the denominator. What about the 10th term?
N plus 1.
It's going to be a 10 in the denominator. So the bottom of this thing is always n. But the top of it is what?
N plus 1.
Yeah, the top numbers are always 1 bigger than the denominator. But let's say that it wasn't that easy. Let's say that it wasn't just exactly 1 higher. Let's say it was something different. How do you get, for just looking at the numerators, how do you get from 2 to 3 to 4 to 5 to 6 and so on? You're constantly adding 1. So your rule is going to be 1n, but then you have to kind of think, backwards and figure out what would the term 0 be. If there was a term 0, what would be
1.
the numerator of term 0 would be a 1. So I am trying to apply the numerators to a linear situation.
Yeah.
I understand that you guys can look at this and notice that the numerators are exactly 1 higher than the denominators. So whatever you come up with for your denominator rule, you just add 1 onto it to get your numerator rule. Does that make sense?
Yeah. Yes.
No.
Oh yeah.
Alright. Let's do this one. Another example.
840.
Let's say you have 3, 9, 27, 81, etc. Alright, what are we doing to get from 3 to 9 to 27 to 81? We're multiplying by 3, right?
Yes.
So what did I say if you are constantly multiplying by the same number?
Exponential.
It's exponential. Alright, so watch what I do. When you write your rule, we are multiplying by 3, so it's going to be 3 to a power of n. Since you are multiplying, whatever you're multiplying by gets put to a power of n. But again, to come up with the number that goes out front, you have to think backwards one step. What were to happen if there were a term 0 in your string of numbers? It would be a 1. So if you had a term 0, a sub 0, right here, it would be a 1. Because 1 times 3 would get you 3. 3 times 3 would get you 9, and so on. So the number that goes out front here is going to be a 1. Will it always be that easy? Will it always be a 1? No, it won't be, but in this case it is. What goes in between these two things, though?
Times.
What'd you say? Times, yep. Yeah, you're multiplying by 3 each time. So it's going to be a 1 times 3 to the n power. All right. Let me look here to see if there's, okay, I do want to talk about one more thing. What happens if you have this instead? If you have a negative 3 to 9 to negative 27 to 81,
Oh, then you're just multiplying by a negative.
yes, you're multiplying by a negative number instead of a positive number. How do you know? What is your first clue that you're multiplying by a negative?
It's a negative.
Yeah,
And then a
swap.
positive.
That's actually not true. It's
know.
not. It's
You
not
can flip
because
back
if
and
they
forth.
were all negative, you'd be multiplying by a positive.
Yeah.
Every other number is a positive, switches from a positive to a
Yeah.
negative. All right. So what are you starting with in this case?
-3, or no, a 1.
What would be out front? There would be a positive 1 out front. So your rule is going to be a sub n is equal to 1. Again, it's 1. But instead of multiplying by 3, you are multiplying by negative 3. You guys make sure you do this.
Oh,
You have to put parentheses around that negative 3. Otherwise, you are only multiplying by 3 each time.
Can we do another
what
one?
about for the last
Yes, we're
one?
going to do one more. Let's say we do this. I don't know that they necessarily get a lot harder than these.
That's okay.
All right, your example, one more example. What if it's not starting with a negative 3 to a 9 and so on? Let's say it is starting with a 3 and going to negative 9, going to 27, going to negative 81. So again, we're flip-flopping between positives and negatives.
The 0 terms negative.
Yeah, the 0 term, you're just starting with the number that would be out front would be a negative 1 instead. So your rule in this case is going to be what?
It's going to be negative 1 times 3 and
Negative 1 times what?
3.
3 to the power of n. Yeah. No?
Is it, well, if we want negative 1 times
Negative
3, we would get negative 3.
Negative 3 to the power of n.
Yeah, we're still flip-flopping between positives and negatives, and whenever that happens, that means the number that you are putting to a power has to be negative, and you have to have those parentheses there. Okay? All right, one more thing I want to make sure that you guys are comfortable with is this. Let's say that you have a situation where you have to do this. Let's say that I give you a rule, a sub n is equal to 2n plus 3 over n minus 7. Let's say that's the rule. And your job is to find the 28th term.
Oh.
So are you going to list out all of the numbers until you get to the 28th term?
Probably.
Please do not do that. Please rely on your calculator. Type this into your calculator. This is what I want to make sure that you guys are comfortable with. When you type this into your calculator, please make sure that you are separating the top with its own set of parentheses. This will be a mistake that I'm very confident that some of you will forget to do. You need to make sure that this numerator, 2x plus 3, is separated from its denominator of x minus 7 if you type it into your calculator. Okay?
Yes.
Also remember, when you are working with fractions, if the terms in your sequence are fractions, please make sure that you are looking at the numerators separately from the denominators. They may have two completely different rules.